Welcome, Algebra 1 to Lesson 7.3. Today, solving systems by using substitution methods. So we've graphed those. Now we're going to look at some more algebraic ways to solve. So what we have here, again, two different equations. And substitution method is pretty neat because we're going to look at these kind of as two different equations, of course, but I'm going to use two different colors. And what you can essentially do is, since we know that y is two things, we know that it is 7x plus 13, and we also know it is negative 8x minus 17, what we can do is substitute this y, this 7x plus 13, into the y in the blue equation, in the second equation. So what that's going to look like is literally taking that equation and popping it in where y on that other side is. So basically you have 7x plus 13 is equal to negative 8x minus 17. It takes the place, it substitutes in for that y on the left. So that is substitution. Now once you have that, then it's just a general old regular algebraic equation. So if you remember adding 8x to one side, we're just solving for regular x, solve for x from there. So step one, kind of substitute. And 7 plus 8 is going to be 15x plus 13 equals negative 17. And subtracting negative 13, 15x equals negative 30. And dividing by 15 means we get x equals negative 2. Okay, which is great. But wait, there's more. So remember when we graphed, we always had two coordinates. We just found the x coordinate. In order to find the y coordinate, you are then going to, once again, substitute negative 2 back in for x in one of the original equations. So if I take the blue equation, and I now have y equals negative 8 times negative 2 minus 17. That means y is equal to 16 minus 17, and y equals negative 1. So that gets you the other point. You need two coordinates, two answers for each of these, x and y. Okay, so basic steps, substitute, solve for x, and then substitute again to get both of those coordinates. Let's look at another example of substitution. This one a little bit different. We have the top equation solve for y. So y equals negative 3x plus 24. The bottom equation not solve for y. But once again, what we can do is this top equation we can put in where y is right down below. So substitute, that's our first step. So you make the substitution. 2x plus 4, I'm going to put it in quantity, negative 3x plus 24 equals 16. Everything else stays the same. This time, just distribute. So 2x minus 12x plus 24 times 4 is 96 equals 16. And then we just have to solve. So remember, on the same side, this is going to be negative 10x. Subtract 96. And that is going to be negative 80. And divide gives us x equals 8. Now remember, we are only halfway, more like 3/4 of the way done. This is great, but put back into one of the original equations. You could use either one. You could actually use the purple equation. However, I'm going to use the blue equation, y equals negative 3 times 8 plus 24. And that's negative 24 plus 24, which is 0. Don't be afraid. Y is able to equal 0. 0 is a good number as well. 8, 0, and that's your answer for number 2. So the substitution method. Let's look at one more here. This time, again, y is solved in the bottom. So you can see all the different types here. It's just going to go up top there. So take the top equation. I'll write it over here. Negative 5x plus 3 times negative 6x plus 5 equals negative 8. Distribute. So negative 5x minus 18x plus 15 equals negative 8. And start to combine our like terms. So negative 18 and negative 5 is 23. And that equals negative 23. So x equals 1 when you divide. Put that back into any of the equations. I'll put it back into the top one. So negative 5 times 1 plus 3y equals negative 8. And that means negative 5 plus 3y equals negative 8. So depending on which one you put it back in, you may have more or less work to solve. 3y equals negative 3, and y equals negative 1. So we have 1, negative 1, x, y, that is also important, are your answers. Okay? Substitution method takes a bit of practice, which are right down below. Make sure you check out your answers to those. And good stuff, guys.